Okay, correlation. This is absolutely central to what you are going to be doing in your analysis. In fact, correlation sits underneath a whole bunch of statistical analysis. If you don't get this, you can't get the other stuff. So make sure that you get your head around this. If this video doesn't help, jump online, type in correlation explanation for dummies, correlation simple explanation, whatever. Just make sure that you get your head around this idea. But hopefully after this, it'll make perfect sense. Some of you will know exactly what this is and you will be able just to watch this as a revision. Anyway, I hope it helps. So what we're looking at is this idea that coffee consumption increases stress. So over here we're going to ask people what their level of coffee consumption is. How many cups of coffee are you having per day? I know some of you are probably up above 7 by now, but anyway, we'll stick with 1 to 7. How many cups of coffee are you having? And for each and every one of those people, we're going to ask them what their level of stress is. We'll ask them a bunch of questions. How often do you have palpitations? How often do you sit in the corner and rock backwards and forwards? But what is your level of stress? And so every single one of those people will get a score from 20 through to 100, or from 0 through to 100. And so what we're going to do is, in a correlation, we want to keep those two pieces of data together. So for each one of those, we're going to have a look, and so we're going to think, okay, we've got Bob. And so Bob, he has about 2 cups of coffee per day, and he has a stress score of about 20. Now Jane, she's got a stress score of about 80. Let's go with 80. This is not necessarily Jane Bowden Dodd, but any Jane, and her coffee is about 4 cups per day. And so we end up with a whole bunch of different points, each of these points representing one person, okay, on 2 data points. So we've got all of these points, and this is the first thing you need to understand about correlation. So a correlation is effectively a way of understanding data, 2 pieces of data, how they fit together and what pattern they fulfill. Okay, so that's the first thing. If you understand that each one of these represents one person or one point in a data set, whether it's, doesn't matter what it is, but so it's the relationship between the number of coffees they drink and their level of stress. So each one of these crosses, in this case, and in psychological research, generally represents a person, but it can represent other things. Okay, so that's number one. The second thing is what's called the line of best fit. Now, all this line does is it tells us, it basically estimates the data that we have. So it gives us an estimation of what the relationship between these points are. And so if we have a look here, we've got all of these data points, and so we might end up with, well, that line's not very big, we might end up with a line that runs something like this. Let's just stick with a straight line for the minute. Okay, so we might end up with a line that runs straight like this. And what this tells us, that this line is the closest line that we can get to represent each and every one of these data points. Now we know that it's not perfect, right? So this point over here, we know that it's a long way away from over here. Let's change the color of that. Or not. That it's a long way away from over here, and this one is quite a long way away from over here, but this line is as close as you can get, okay? So the line of best fit gives us an estimation, and there's actually, can't remember whether you'll learn a formula, but there's a formula that will capture this line that basically says, okay, this is the line that captures this relationship between these 2 data points. And what this allows us to do is, even if we don't have data, we can actually estimate, even if we don't have how many cups of coffee a person drinks or how much stress we have, we can estimate the other one based on the first one, okay? So the line of best fit tells us, gives us an idea of what that relationship is. Okay, so now, what happens is you end up with, so when you're looking at correlation, you'll end up with an R score. Now don't be freaked out by this. R equals point something. Now it can be point anywhere between -1 and +1, and we'll talk about that a little bit in a minute. But let's go with positive. Let's not go with +1. Let's go with positive 0.5. Not entirely sure why it's changing the colours on me. Let's go with positive 0.5. So what this tells us, the first thing we need to look at, right? So you understand that this is going to capture some of the information in a correlation. So the first thing we need to look at is that R score positive or negative? Because that tells us something about the way that the data relates to one another. So if it's positive, what it tells us is that when coffee consumption goes up in the population, so does stress, okay? So it tells us that this line is going up, okay? So if we have a person who we know is only having 1 cup of coffee per day, it's likely that their stress level is going to be around 20, right? We know that life isn't as simple, but we'll just for the example. But if on the other hand we have a person who's drinking 6 cups of coffee per day, we know that it's likely that they're going to have a stress level of around 70, okay? So plus means that when one goes up, when coffee consumption goes up, stress goes up. When one variable goes up, the other goes up. Now, negative. You might have guessed by now that negative is just the opposite. Okay, so what negative tells us is if one goes up, the other goes down. Okay? So a negative, so we're not paying attention to the numbers at the moment, just the positive and negative, but a negative, what it tells us is that if coffee consumption is high, then stress is likely to be low. Okay? So if coffee consumption is all the way up here, then we have a look at this, and our stress is likely to be 20. Whereas if coffee consumption is really low, 1, then our stress is likely to be 100. Okay? So a negative correlation means when one goes up, the other goes down. It doesn't matter what the variables are, it just means that when one goes up, the other goes down. Okay? So that's your negative and positive. So remember, the first thing, we're talking about a relationship between 2 variables over a population. The second is the positive or negative. If it's positive, when one goes up, the other goes up. If it's negative, when one goes up, the other goes down, or vice versa. Okay? All right. Now, the final thing. So, we've got a bunch of information here. We've got this R score equals either plus 0.3 or equals minus 0.3. But this score can vary anywhere between -1 all the way through to +1. Okay? Now the number tells us something about the data. So if we have a look back at this one, what you'll see is that the data does not fit perfectly along this line. Okay, there's a gap. So when we've got this data point over here, what it's saying is that it's reasonably accurate, but it's not perfect. Okay, so what the R captures, what that number captures, is how closely this data fits to the line. Okay? So here, it all fits nicely. Fairly nicely. So it's this long ellipse. So the closer it is to the line, the closer your R score is to positive or -1. Okay, so to the outside. But if we had a data points that were over here, then our R score wouldn't be as strong. It would be much closer to 0. Okay? So let's do a quick example. So our line of best fit okay, so we've got a line there. Let's stick with that. And an R equals 0.3. So think to yourself, is this close to +1 or -1? If it's really, really close, then these points are going to be right on the line. Okay, so if we have an R score of 0.9, 0.9, then the data points are basically going to be along the line. They're going to be, we know that it's positive, because it's when one goes up, the other goes up. But if it's 0.9, so closer to 1 than it is to 0, then they're going to be basically along the line. Now the same is the way in the opposite direction, okay? So if we had points basically along the line, but going down, then the R-score would be R equals point or negative 0.9, okay? So if they're close to the line, it's a number that's either near positive 1 or negative 1. If they're a long way away from the line, it's closer to 0. So 0.1 to so basically anything closer to 0. If it's 0, it means that there's no relationship at all. So you're looking at data that's basically a circle. You know, that kind of, there's just no relationship there. So, quick recap. Firstly, 2 points of data. We're trying to see if there's a relationship between the 2 points of data. Secondly, what we're trying to see is the line of best fit. So this line of best fit tells us how the data relates together. It gives us a way of estimating what someone's score in one variable is going to be if we have the score in the other. The third is that positive means that when one goes up, the other goes up. When one goes down, the other goes down. Or negative means that when one goes up, the other goes down, or when one goes down, the other goes up. So it's this kind of opposite relationship. And the final thing is that R, the closer it is to either positive 1 or negative 1, the stronger the relationship is, the closer it fits to that line. Whereas the closer it is to 0, so negative 0.004, negative positive 0.0, whatever, the less perfect it is, so the more rounded it is. Okay, I hope this has helped. If it hasn't, make sure that you jump on YouTube. There are plenty of people there explaining this stuff. Jump on, watch a few, the penny will drop for you, and then you'll know what it is. If you don't get this stuff now, it is going to be your nightmare for the rest of the semester. So make sure you get your head around it now, otherwise it's going to come back to haunt you. Thanks, see you next time.